discuss the integral, like the definite integral is to represent area under the curve. The indefinite integral is to represent when you have f dash x function, you want to find back to fx function. So we talk about the area under the curve. Let's see this graph. Okay, all the fx is above the x-axis. And when you do integral from a to b fx, that is a positive area. Okay, that is a positive area. So we have this graph. Everything just below the curve, okay, just everything below the curve, below the x-axis. And then when you talk about that area from A to B, okay, above the curve and between the x-axis. So this area, if you do, like, let's say if that area is 3, like the actual area is 3, when you go A to B fx dx, that will give you -3 instead of 3. Okay, that will give you -3 instead of 3. Therefore, when they ask you, okay, the question may ask you, what is the area under the curve for this part? Or what is the shading area? You won't answer a negative value. You should answer a positive value. Okay, you should give a positive value. Therefore, you can do like 2 ways. One, you can negative the whole thing. You put a negative sign in front, you negative the whole thing, that should give you a +3. Or you can just, okay, I'll talk about the have I talked about the properties? Yeah, I have talked about the properties. So, or you can change the upper limit and lower limit. Make A on top and B under the bottom, that will negative the area as well. Okay, remember that, that will be negative of that. So that they are equivalent. So fx dx, that will give you 3 as well. I will recommend you do this method, or you just do normally from A to B and find that's a -3, and then you will answer the question as the area is 3. Okay, the area is 3. Yep.
So if you get to put the negative on it, you end up with negative values, you will need to do it anyway.
Like for this, for example, this one, if you do normal way, and you will realize that's a negative value. But like the thing is, everything must be below the curve. Like the whole area is below the x-axis, not like part above, part below. You can't do that that way. So I'll show you an example later in the next example. Okay, this one, I'll talk about this one later in the next session. So that's everything below the x-axis, okay, everything below the x-axis. Now we have mixed area. Like your graph always have x-intercept going up, going down, and the area can be mixed. Okay, let's just see this diagram. I'll just let you know that, okay, if you have, let's say that's 5 and that's a 2. Okay, that actual area is 5 and 2. Your answer should be 7, right? Your answer should be 7. The area should be 7 in total, the shading area. But if you do, okay, A to C, because it starts from A, finish at C. If you go A to C fx dx, that will give you 5 minus 2. That will be a +3. That is still a +3, but it's not the actual area for this 2 shading region. This is called the signed area. Okay, we sign take into consideration. Okay, we take the sign into consideration. So what we should do, we have 2 ways to do it. First is by hand approach, like we just do manually without cats. So without cats, we'll see. We will find the x-intercept. In this case is B, right? In this case is B. That's the x-intercept. Well, the x-intercept will change the graph from positive to negative or change negative to positive. Where your graph changing the area, like above and below. So B is the separate section. So in between A to B is all above the x-axis. So what you can do is from A to B, fx and dx, and this will give you a +5. This will give you a +5. And then think about the area between B and C, in between B and C. If it's in between B and C, that is a negative area. What you need to do is negative B to C fx dx. That should give you a +2 as well. That should give you a +2 as well. So overall, what you should write is A to B fx dx, the positive sign, minus the negative area. That will become a plus sign. So that is 5 plus 2 gives you 7. 5 plus 2 gives you 7. That is like do it by hand, okay, without CAS. Okay. If it's with CAS, what we can do, okay, that's so much easier if we have CAS. Okay, if we have CAS, it's so much easier. While there's a button, we can directly find everything. So, okay, for special students, you definitely know like absolute value. Methods, we don't really have that in the course, but we still want you to use this function. Okay, we still want you to use this function. What absolute sign, like, or we call modular sign, what that sign will done. So let's say the modular sign is 2 bar, okay? You put some value in it. Let's say we put -2 in it. That will comes out with a 2. It will get rid of the negative sign. You only have the positive magnitude. So if you have a positive 2 coming in, you still have a positive 2. So positive value will remain the same in the absolute sign, and negative value will change into positive value. Okay. Now, if we have over fx looks like that. If we have over fx looks like that. Okay, that's over fx. Okay, this blue graph. This is fx. Oh, I should write in blue. If I put a modular sign around this, what the graph will look like? That will change all the negative value into positive value, will reflected by the x-axis. So the graph will become, okay, this is the negative part, that will reflect up. And you still have this positive graph, and this negative area, this will reflect up, and positive will remain the same. So this green graph is the absolute fx. Your graph will change into this shape. Okay, the graph will change into this shape. And the two areas you considered before will become this one and this one, right? It's just directly reflected. The area won't change. Anything won't change. So the two areas you're talking about now in the new function will be the two black shading region. Okay, the two new shading region. So it's all above the x-axis. Everything's positive now, and we are happy about that. So if that's the case, number 2, what we can do is directly, I don't need to worry about where's the x-intercept because everything is above the x-axis. So I can just say start from A, finishes at C, and we put absolute sign around it and dx. That will directly gives you the area of 7. That must done by CAS. Okay, you can't really do this by hand. You definitely do this by CAS. I'll show you an example later. Okay, I think it's the next example. So you change, it basically is you change the function, but not change it like completely. You just reflect the negative area into the positive above the x-axis, and then everything is above the x-axis, and I just need to worry about the starting point and finish point. I don't need to find x-intercept, save a lot of time. Multiple choice questions, definitely do by that. But you need to read the question carefully, whether it's asking a total area or it is asking a signed area. If it's signed area, you need to just do 3. Okay, that's the signed area. That's just normally integral a to c for fx equals to 3. That's the signed area. If you think about total area, that will be this one. That is the total area. Okay. Most of the time, like 90% of the time, it will ask total area. They're not interested in the signed area, like what that used for. It used for in kinematics, like when we think about motion, we use that signed area, but like we'll talk about that later. So, okay, let's have a look at this. Example 1. Well, basically you can ignore example 2, like the second notation. You don't really need that. You just think about first by hand, third by CAS. Well, second is also correct, but just not like increase that much confusion. Okay. Okay, the absolute sign is inside the integral, okay, near the fx, not outside integral. It must be inside the integral. Okay, example 1. For each of the following shaded regions, write down the integral that represent the area and evaluate the integrals to find the area of the exact form. Okay, let's have a look at the first one. A is just a graph all above the x-axis for the shading region. So that's easy, from 0 to 3 of that function, dx. Okay, everything above the x-axis, so easily just done normally. And I will integral that. I will have 3 over 2 x squared minus a third x cubed, 0 to 3. Okay, I'll sub 3 in. 3 times 3 is 9. 9 times 3 is 27 over 2 minus, okay, a third. 3 times, well, take a 3, cancel with that a third, you're left with 2, 3, that is a 9. That's your first substitution for 3. And the second substitution is 0. Well, you have 0 minus 0. That is basically a 0. So 27 minus 18 over 2, that should give you 9 over 2. Okay, the actual area is 4.5. The actual area is 4.5. Okay, B. B is all below the x-axis. Well, that's also good. Okay, all below x-axis, that's also good. So what I can do is I put a negative sign in front and integral that normally 0 to 4 x squared minus 4x dx. Okay, remember to write the dx. I find a lot of students just ignore that dx, just write integral something, and there's no dx. Well, that's together, okay? The integral sign and the dx, they are like together. Without the dx, you can't integral the thing. You can't find the anti-differentiation. So that's a minus. Minus what? Okay, that's a third x cubed minus 2x squared, 0 to 4. Okay, remember this negative sign is still in the front. It's still in the front. If you really don't like it, just don't put the negative sign at the beginning. Calculate normally and then change the sign in the end. Say the total area is positive of that value. Well, it's very confusing if you put this negative here and you do some wrong calculation. So that negative is actually negative a square bracket, a small bracket, you sub 4 in. Okay, 4 times 4 is 16, 16 times 4 is 64. So 64 over 3 minus 4 times 4 is 16, 16 times 2 is 32. Okay, that's your first substitution, minus 0 minus 0. And you still have the square bracket. Okay, the minus is the negative of the whole thing you calculate. So that's a minus. I can change that to a round bracket. 6 over 3 minus 3, 96. And that's positive 96 over 3 minus 64 over 3. That you have 32 over 3 positive. 32 over 3 positive. Okay. That first exercise is everything above the x-axis. Second exercise is everything below the x-axis. And the last one is a mixing area. Mixing area. So mixed area. Some above, some below. Okay, some above, some below. Okay, I'll just do hand approach first. In between negative 3 to 0. Okay, you look from the left to right. Negative 3 to 0 is above the x-axis. Okay, this function here, I can say that's y equals to x cubed minus 9x. I will expand it directly. You can't really integral for x times that. Okay, what we can do here is, okay, C. We can integral from negative 3 to 0 normally for x cubed minus 9x dx. Okay, now I can't class them. I will subtract 0 to 3, I need to put a negative sign in front of that. Subtract 0 to 3, x cubed minus 9x dx. So what I will have is a quarter x to the power 4 minus 9 over 2x squared, negative 3 to 0, minus, okay, the integral will stay the same. The integral is the same as before, but you put 0 to 3 here. Okay, that's 2 integral, okay? That's 4, you can expand to 4 expressions. Sub 0, sub negative 3, sub 3, sub 0. So what I will have is, well, sub 0 is basically you get a 0. So I have a square bracket, I have a 0. And minus the second from sub negative 3. When you sub negative 3, 9 times 9, 81, 81 over 4, minus, okay, 3 times 3 is 9, 9 times 9 is 81, 81 over 2. That's the first integral. And the second, okay, I will have, you sub 3 in, 81 over 4 minus 81 over 2, subtract 0. What I will have inside here, this one will give you 81 over 4. Okay, 81 over 2 minus 81 over 4, that is 81 over 4. A half of the thing, subtract a quarter of that thing, you'll have a quarter of that. Okay, a half subtract a quarter will be a quarter of that. So it's 81 over 4. And I'll subtract what inside here. A quarter subtract a half is negative a quarter of it. You have that. And overall you have 81 over 2. A quarter of that plus a quarter of that is a half of that. Okay, so 81 over 2. Say if we just have calculator. If we have calculator, I can directly go from negative 3 to 3 and absolute sign x cubed minus 9x. Absolute sign dx. Okay, I will flip that into the front, like in the top, like that. The function becomes this, and the two areas we're talking about will be those two areas. Here, that is my new graph, and I'll just talk about negative 3 to 3 after the absolute of x cubed minus 9x. So if I have my calculator out, I can have, okay, integral sign again is the shift button and plus. You can directly have the integral. Okay, the shift plus is the integral from negative 3 to 3. Okay, where's the absolute sign? The absolute sign is next to the 9 button, to the right of the 9 button, and is the second line, first one. Okay, second line, first one. Okay, just click on it. Oh, click on the wrong place. Go here. Okay, and you have this, and you type the fx in it. So x cubed minus 9x dx. Okay, 81 over 2. That's the same as what we find. Okay, 81 over 2. You can directly find that back as. We'll have a more complex one later. Oh no, you don't need to expand it. You can put the original function in. Okay, so that's an easy example. Let's do a complex one. Okay, example 2. Example 2, let's say sketch this graph first. Okay, stating all the intercept and asymptotes. Okay, let's sketch this first. Okay, just a little bit revision on how to sketch exponential graph. Exponential graph will look at Okay, the value we're looking at is, first is the C value. The C value is -3, so I will have asymptotes at -3. Y equals to -3. And then I was thinking about the base shape. Well, E is a positive, like a number greater than 1, I'll have positive shape like that. And then I get reflected negative x, okay, negative x, reflected in the y-x-axis. Reflect in the y-x-axis. So your graph will look like that. 2 is positive, the capital A value is positive. I don't need to get reflect for that. So I should have a graph shaped like this. Okay, shaped like this. But I need to find xy intercept first. Let's find when x equals to 0. Y equals to 2e to the power of 0 minus 3. Y is 2 minus 3. Y is -1. So I'll have -1 here. Okay, 0 minus 1. Next thing will be when y equals to 0. 2e minus x equals to 3. E minus x equals to 3 over 2 minus x equals to log e 3 over 2. X is minus log e 3 over 2. Or like I can make this value looks like that, or log e 3 over 2 to the power of -1. I can put the -1 onto the top, and that is a log e 2 over 3. I can put that as well. Well, this or this, both correct. But like I will know that's a negative value. I will know that's a negative value because the log e graph looks like this. This point is 1, 0. That's 1, 0. So 2 over 3 is here. That's a negative value. Okay, negative. So I'll have like, I don't know how large is that. I don't care. Just here, maybe. So let's go for this shape. And that shape. Okay, that's your exponential graph. Well, you should draw it really smooth. Okay, that's better. So this point is log, I will say as minus, well, it doesn't matter which one, minus log e 3 over 2, 0. Okay. Then what I'm trying to do is find the area of the region. Okay, find the area of the region bound by something. Bound by what? By this curve. By x-axis. By the line x equals to -2 and x equals to 2. Okay, let's sketch x equals to 2 first. X equals to 2 is this line. Well, where is x equals to -2? If I want to know where is x equals to -2, I will think about whether it's to the left of the x-intercept or to the right of the x-intercept. That's very important. Why that is important? Because if it's to the right of the x-intercept, then all the area bound will be below the x-axis. That's easy to deal with. But if you go to the left of the point, that will be part positive, part negative. Then it's hard to deal with. So I need to make sure the -2 will be to the left or to the right. Well, according to my scale, it's definitely to the left, but I need to confirm that. I can't just think it's to the left. So I will compare the 2 points. Minus log e 3 over 2 and -2. I want to see which is smaller, which is larger. Well, instead of compare the negative sign, I will compare log e 3 over 2 and 2. Well, what is 2? 2 is log e to the power of 2. That is 2. Okay, log e to the power of 2. I want to make the same thing. And the next thing I will compare is 3 over 2 and e to the power of 2. Which one do you think is larger? E to the power of 2 is larger. 3 over 2 is 1.5. 1.5. E is 2.7. Well, 2 squared is 4 already. 2.7 is even larger. So 1.5 is definitely smaller than 4. So this is a smaller sign. Therefore, this will be a smaller sign here. Because the larger the value you put into log, the larger the log you will have, the larger the y value you will have. But if that is smaller than that, then this sign will be greater because you will flip the sign. Negative of that, you flip the sign. So this value is greater to negative 2. This value is greater to the negative 2. Which means negative 2 will be to the left of this point. Okay, negative 2 is smaller than that, is to the left of that point. That's how you compare values. So I will sketch negative 2. My negative 2 will be here. Well, what is the area we're talking about then? The area we're talking about is this area. Okay, bound by the curve by negative 2 by the x-axis. And this area we're talking about. Okay, those two are the area we're talking about. So this point is negative 2. This point is actually 2. So what I should do is, well, 1 positive, 1 negative. Okay, 1 positive, 1 negative. I'll just clean this part. Well, I'll say negative log e 3 over 2 and negative 2. That's greater. Log e 3 over 2 is smaller than 2. 3 over 2, well, that's log e to the power of 2, and 3 over 2 is less than e to the power of 2. Okay, going backwards. Okay, so what I should write here is integral of negative 2 to negative log e 3 over 2, and the function is 2e minus x minus 3 dx. I'll write it smaller. 2e minus x minus 3 dx. And then minus from negative log e 3 over 2 to 2 of this function. Well, I can put a bracket. Better put a bracket around that. Okay, so the next thing we're trying to do is integral and substitute values in. Okay, integral and substitute values in. So the integral of that will be minus 2e to the power of minus x minus 3x. The value I should substitute is those two values. Minus, well, same integral. The function doesn't change. The integral remain the same, and I will substitute that and 2. Okay, a lot of calculation. That's minus 2e to the power of log e 3 over 2. Minus, like minus minus is a plus. 3 log e 3 over 2. Okay, that's the first, well, that's the first one. Okay, I'll square bracket. Subtract. When you put minus 2 in. When you put minus 2, that's minus 2 e to the power of 2 plus a 6. Like that. Bracket. You sub first value in, you sub second value into function. And subtract. Now you want to substitute 2 into that. 2 into that. That's minus 2e minus 2 minus 6. That's your first substitution. Subtract. Second substitution, minus 2e to the power of log e 3/2. And plus 3 log e 3/2. Square bracket. Finished. Well, what is e log e 3/2? E to the power of log e 3/2. 3/2. It's just 3/2. So what you have is, let's expand everything. That's minus 2 times 3/2 plus 3 log e 3/2 plus 2e to the power of 2 minus 6. Okay, I'll still keep that bracket. I will expand the bracket in the square bracket first. That's minus 2e to the power of minus 2 minus 6. Okay, that is a plus 2 times 3/2. And I have a minus 3 log e 3/2. Okay, expand the bracket in the square bracket first. And I will have minus 3 plus 3 log e 3/2 plus 2e to the power of 2 minus 6 plus 2e minus 2 plus 6 minus 3 plus 3 log e 3/2. Okay, what can be cancelled? That's 6, that's 6. Nothing else. Nothing else. So what I have is, okay, number first, we have this 3, and this 3, we have a minus 6. We have that, we have that. That will give me 6 log e 3/2. And I have this one and this one. Well, they are just plus e to the power of 2 plus 2 over e to the power of 2. Can't do much about it. That is the actual area. That's a lot of calculation, but like this can be a part 1 exam. Part 1 exam question, like this type of question. It's quite achievable by hand. And it's about like 3 marks or 2 marks or 3 marks. It involves sketching. Well, I think in total that's 40 marks on paper 1. So 3 marks is a lot. Okay, so let's put that into CAS to see what that equals to. I'm not sure if I have made any mistakes in between or not. So let's just check. That's plus 6 log e. Well, ln is log e. Okay, ln is log e. So ln is log e. So plus that. And plus 2e to the power of 2 plus 2e to the 2e to the power of 2. Is that correct? Okay, that's about this area. I'm not sure, like I'll check. So that's the region, and if I use CAS, okay, if that's CAS question, I can just say negative 2 to 2 absolute sign 2e minus x minus 3 absolute sign dx. Okay, if that gives me a wrong solution, let's pretend that's correct and go back home and find where it's wrong. minus 2 to 2 to okay, absolute sign is inside here. 2e to the power of minus x and minus 3px. Well, that's correct, yes. Very stressful. Well, that's correct. Okay, so that shows like the cast way will work and the hand approach will work as well. Okay. So that, but like the thing is, in cast it won't give you an exact expression. That will only give you a approximation expression. Let me see if I change this, that will work or not. Okay, settings, document setting. I'll change that. Well, don't change on yours. Okay, don't change on yours. I'll just change this time. I just want to check. Now, see, that won't evaluate. If you keep that in exact form, the calculator say, well, it's too hard for me to do it, so I'm not going to do it. So it won't give you exact value. If you want exact value, you need to do it by hand. Make sure you're not changing that, okay? If you change that, in a lot of cases, you won't find the value. You will say like fail or something like that. So calculation mode must be what I'm doing. Calculator must be under auto. Why? Okay, make default. Okay, make sure you press make default and don't need to change it every time. Must be under auto. Okay, so that is area under the curve. You have a single curve, that area under the curve. That's what we talk about. Okay, just talk a little bit more about that. Okay, so the good thing about the area between the curve, like you have two curves now, you have fx and gx, and they will intersect somewhere, or not necessary to intersect. For example, you can have this situation. Well, I'm not going to do examples. You just need to listen what I have explained to this. And next lesson, we can start to do questions directly. Say we have fx here, and we have a gx here. Not necessary to have intersections and to find the area between the curve. I can just say we want this point. That's A. And that's B. I can find in between A and B the area under the curve. I can find that as well. Not necessary to have intersection point. I just see where I stop, the vertical line. Okay, the vertical line, where I stop, where I start, where I finish. Okay, so don't worry about anything. The good thing about region the area under the curve is you don't need to worry about at the curve whether it's above x-axis or below x-axis. What you need to worry about is which graph is on top of which one. Okay, like the x-axis just doesn't work now. Like you just see which curve above which one, which curve under which one. You just always use the top one to subtract the bottom one. Always use the top one to subtract the bottom one. Okay, for this question, who is on top? Like for that region, who is on top? fx is on top. So that will just be fx subtract gx from A to B. Integral fx subtract gx from A to B. Okay, case number 2. Doesn't matter where is it. Okay, doesn't matter where is it. Which is on, who is on top? fx, then fx minus gx from A to B. Okay, you just need to see which is on top. Let's just show you another example. Say we have a graph here, and we have a graph here. Okay, that is A, that is B. And I want this region. Well, in the past x-axis for both graphs, it doesn't matter. It's still like this is fx and that is gx. You still use A to B, fx subtract the dx. Well, doesn't matter where is the x-axis, you just see which graph is on top of the other one. Okay, use the upper one, subtract the lower one, and then integral from the point they start and they finish. Okay, I like this case. It's not mixing area now. It's just like one graph always above the other one. But the next situation will be terrible. Okay, the next situation will be terrible. Okay. The red one is gx, the blue one is fx. Well, it's just twist, okay, and it's changed like 3 times. So for A to B, from A to B, you will use gx subtract fx. From B to C, you use gx to subtract fx. From C to D, you use gx, fx subtract gx, which is fx. Well, the blue one is fx. Okay, C to D is gx subtract fx. B to C is fx subtract gx. A to B is gx subtract fx. So just see which one is on top. So you will have something like that. Okay, this long expression here. Okay, gx subtract first and fx and then gx on top back again. Okay, calculator is wonderful again. Why? Because it doesn't matter. You just want to see where is the region you want to. Okay, I want the areas from A to D. I want the area bound by the curve from A to D. Doesn't matter which one is on top, which one is below. You just use one graph, subtract the other one, and put absolute sign around it. Use one graph, subtract the other one. Well, it doesn't matter which one in the front. I can use fx to subtract gx or use gx to subtract fx. Just put absolute sign there. Just put absolute sign there. And that will give you the same result. Just from A to D. Okay, I start from A, finish at D. I don't care which one is on top. I don't really need to see the graph even. I just use one graph to subtract the other one, put absolute sign on it. So that must be a CAS question. You can do this. Okay, that must be a CAS question. Well, even though it doesn't matter, maybe it's not twisting, it's just like, for example, this case, I can still put absolute sign on it, doesn't hurt. You can always put absolute sign around it, doesn't change anything. So now you don't need to worry about which one I should put in the front, which one I should put below, like after that. So what you have is absolute sign here. Okay, how many examples you have? We have 3 and 4. Could you please try example 3 and example 4? If you don't want to try it, just at least sketch the graph, okay, before next lesson. Sketch the graph for example 3 and example 4 for next lesson. Because if we don't have CAS, we need to still see the graph and then figure it out. Okay, so I'll just stop here today.